This week's episodes were brought to you by Snoopy. Hey folks, Quilly18 here, and welcome to another episode of Let's Program Project MightySpud in Unity here. Now, this episode, I'm really running into, in a particular area, my probable limits about what I can sort of do and figure out. Doesn't mean the series is going to come to the end, but there's going to be a couple more of those fix me comments that are going to be left in the code, and hopefully someone else can figure out some of the nitty gritty. But you'll see what I'm talking about when we get there. So in the last episode, we got it so that our little cool base structure over here is spawning in the map and is part of the correct object, although even this has some issues, as we're going to discover going forward. What we need this to do, though, is rather than have it right now, it's just spawning at the origin world space 0, 0, 0. Yeah, it says it's got a position here, but this is just the inverse of the chunk that it's in. We need this to spawn here on top of this little elevated crater bit in the middle. That's where it's supposed to show up. So we're going to go ahead and get that going. So what we're going to do in dynamic terrain chunk over here, way down here, we've got this excessively large and wonky function, which does have to be trimmed in a few bits. Because one of the things we want to do is, first of all, we shouldn't, ideally, we don't want to have to parse the building map for every chunk. Instead, it would be nice. It would be that and a period. It would be nice instead if we did this once and just cached where all the buildings should be. This is actually very easy. This is actually a very easy thing to do because it's actually quite trivial. In our coordinate helper, we did this UV to rotation, but more importantly, and that's fine and relatively easy. Also, what's relatively easy and actually it's trivial is UV to spherical coordinate. So this is going to return spherical coordinate, and it's going to return new spherical coordinate like this. Basically, we can take a UV and convert it to a latitude and longitude. Easy. Easy thing to do. No problem whatsoever. That's fine. Okay? The hard part, and then what we can do, when you could parse through our image, find every building, right? When we're loading through here, we can find every building and just store it in some sort of, some sort of data structure, some sort of list or dictionary or something, where for each building you keep it associated with its matching spherical coordinate, and that's that. So that would be very easy to do. You could just do that one time. That's not the part that's hard. The part that's hard is actually this part not technically working right, as we'll find out in a moment, and this part over here. So what we want is some sort of function that is latitude, I guess I'll call it lat long to local position. What the hell is this supposed to be? So this takes in a spherical coordinate, SC, okay? This function converts a spherical, I guess I could have called it spherical, and not location, local position. Spherical to local position. This converts a spherical chord, i.e. latitude, longitude, into into a vector 3 with the position of the the past object effectively with that represents the position of this lat long on this terrain chunk. The reason that this is not part of the chord helper is because it's based on the local chunk. Now, it doesn't actually have to be local position. It could be a global, like, Unity world space position. We're going to say relative to this chunk here because it really emphasizes that you need to start from a chunk, and it's always going to be relative to a chunk. I mean, again, we can have the final vector 3 be in global Unity space or be in local to this chunk space, but it's always going to be relative to the current chunk for sure. So that's the function. This is the function I can't solve to my complete satisfaction. It's really annoying because for every point on the terrain, we've got, I'm pretty, again, I've got this whole, someone smarter than me will have to figure this out. Probably, it might be slightly off, it might not be, I'm not sure. Any offset might simply be a virtue of the fact that, again, we're trying to take a round planet and make it flat. This might be fine. We can, so, point rotation is the chunk, and it's the position, and it's rotating by a chunk. I mean, and then we convert it to a UV. We're starting with pause, and then converting it to a rotation. And a rotation is basically a latitude, longitude, but it's local. It's not, yeah, it's local. It's not starting from a global one. Like, so many of the steps are fine. And what's funny is for every single point on our height map, we know the UV of that spot. And since we know the UV of that spot, that means for every point on our height map, right, for every little bump and crevice that we've got, we know what the latitude and longitude of those spots are. It's just the inverse that has me a little bit burr. Okay, well, let's do what we can here and keep moving forward. So, we've got that. So what we have over here, right, is we have all this code here is actually not quite right. All this code here is not quite right. But luckily, if we solve this, we get this working correctly. Because what we ultimately want is we want to end up in this situation. So what is the position of the building? In fact, instead of taking a rotation, I'm just going to say UV to spherical. So then we get a spherical coordinate, which is we're going to call this one the building latitude, longitude. Okay? So, right, so we pass it this. We're passing it the UV index, basically, because we're doing our x divided by the width, the y divided by the height. So what we're doing is we're passing the UV coordinate of this building to the UV to spherical. And what we're doing is we're getting some spherical coordinates here. So once we've got that, we are then going to be passing this to, so this is supposed to return a vector 3. So vector 3 local position is equal to spherical to local position. We're passing it the latitude, longitude over here. And then afterwards, excuse me, we can confirm if the object is in, because we can just say if local position dot x is less than 0, that means it's not within the bounds of our terrain. It's too far to the left or whatever. I mean, left and right doesn't really mean exactly the same, but it means it's not going to be within the rendered area of our terrain chunk. It's on another terrain chunk, maybe one that we're not even rendering right now. Or if local position dot x is greater than world units per chunk. There we go. Right? Our chunks are supposed to be 124 world units wide. So if local position dot x is bigger than that, then again, we're going to be outside. And then we do the same thing for y. If local position dot y is less than 0, or local position dot y is greater than world units per chunk, then at this point we can say this very easy, not in our chunk. See, already things are looking a little cleaner. I mean, we haven't implemented spherical to local position, but that's great. Right, and then we've got that, and then we can say, okay, well, that's fine, because when we spawn the correct building, we're going to spawn it at local position, but this, even though we pass a parent over here, instantiate still wants a global position, so we want to say actually, I'll rename this to global position is our local position plus the this.transform.position. So this is the chunk's position. So there, the chunk's position and this building's local position within that. So it's going to go there. We still don't have the rotation in there, but we're going to take care of that next. So here's the part that scares me. And I say it scares me because I've already done this video 3 times with 3 different approaches, and every time I end up not getting the math correct, and it's a big thing. This ultimately will be the mostest correct solution to have this function work correctly. I just don't think I can make the function work correctly. So I'm going to apologize for that and have to leave it potentially as an exercise to the viewer. Maybe I'll figure it out in the future, but I haven't successfully done it yet today. Okay, so here's the thing. We're fine-ish as long as our textures are relatively sort of oriented sort of squarely, right? Where, like, I don't know, for example, positive y, well, depending on, God, it's hard to say what sort of coordinate system we're looking at or what frame of reference we're looking at. But effectively, if the positive y is north-ish and positive x is east-ish, fairly square, then we're going to be okay. If we end up doing a twist, which we can do very easily by uncommenting this line, right? So we're on a 45-degree angle, or worse, when we get to the South Pole, things get very, very, very hairy. If I go into Photoshop over here and grab you and make you visible, yeah, there we go. This was an example of what I'm talking about. Imagine this is a single chunk, right? This is a single terrain chunk. And it so happens to be that the middle of the terrain chunk over here is the South Pole, right? I want to be in brush mode, please. Thank you. Right? This is the South Pole. And imagine we have a building that's a triangle, okay? And we have, initially, we've placed the building on the prime meridian, right? So longitude 0 degrees. We place it there, some distance away from the South Pole. And we want the point of the triangle, the sharpest point, to point north. So that's what happens there. But let's say instead of having it on the prime meridian of 0 degrees longitude, we decide we want to have it at 90 degrees east over here, okay? So 90 degrees east longitude instead. But are we still the same distance away from the South Pole, so we're in the same latitude, and we still want this thing to point north. Well, this is north, right? Because it's away from the South Pole, so this is facing north. So this structure is now in a slightly different position. It's also rotated 90 degrees. Effectively, the structure will be rotated based on our longitude, based on also any kind of inherent rotation that this chunk might end up with, right? We have to factor in what kind of rotation this chunk may have, which, to the best of my knowledge, is represented in our code. We have a chunk rotation quaternion attached to each one of our chunks. The x and y part of that quaternion, the Euler angle representation of that quaternion, the x and y part should map to latitude and longitude of this center point, and the z point, the z portion of it, represents the rotation this way. And that should be true. So if we factor in the rotation and the longitude, that should convert to the local rotation of the object. So we can put in a note over here, right? Boom, boom. Our rotation is going to be a factor of our longitude and the z rotation of this chunk in some fashion. I'm pretty sure that's correct, but we'll find out as we go later. So anyway, that's one part of the problem, but we're not going to be dealing with the rotation aspect. We're going to be dealing with the positional aspect, although even this is, where's my Photoshop, is a little hairy, right? So our building, we have a longitude and latitude for our building. Yes, it's been a long day of trying to figure this out. We have that, and we have the position of the center. So, I mean, we can figure out sort of like an offset, right? And, I mean, we know the total distance from here to here, because this is represented by degrees per chunk. So, I mean, we have a lot of this information. So, let's, for simplicity, Although this will probably lead us to making certain mistakes, and we'll figure it out after. But let's assume we're starting from our very initial chunk where we're at 0. Okay, so we're at 0 degrees latitude and longitude. We're at the prime meridian on the equator, 0 degrees latitude and longitude. And we have a building with a... So this would actually be UEV index 0.5, 0.5. No. It would be because our prime meridian is on the seam of the thing. So this would be if we had a building at a UV of 0, 0.5. Okay? So it would be showing up right on the middle over here, or let's say it's slightly further north. That should be okay. So it's got, 0. I guess here it'd be like 4.99, something like that. Okay? That should be fine because we know this is supposed to represent our degrees per chunk, which is 5. 5 degrees is the total thing, so this is 2.5 degrees. We also know that this is 512 world units, right? Because the whole thing here is 5 degrees, or 1,024 world units. Okay. So we're going to ignore the twisting at first and then hopelessly try to fix it. I'm hoping that by working my way through this step by step, I'm keeping track of what's going on. It's not just a question of like trying to make it clear for you guys. I know this is too slow for a lot of you, but it's not too slow for me. Okay. So, all right, assuming everything is square, then we need to know how far off from the center we are in terms of rotation. Okay, which we could have as all as Euler angles or something like that, right? Because, so it's a little annoying in that if we have a quaternion, we can't convert, there's a lot of little simple math that you would hope that you could do that you can't do, but that's all right. So I guess what we'll do is we'll go back to having an x angle difference, which is going to be our spherical coordinates dot latitude minus our chunk rotation dot Euler angle dot x. Yes, because rotations around the x-axis is your latitude, because rotating around the x makes you go higher or lower. So that's going to be our difference in x. Then we'll do the same thing with y. Y angle diff is sc dot longitude minus chunk rotation dot Euler angle dot y. Now, again, this is not accurate because we haven't like rotated this based on the z. Like, so I'm wondering if fix me. Do we need to convert SC into a rotation that has been twisted or inverse twisted by chunk rotation dot z. Oh, I just realized I didn't embiggen my font here. Terribly sorry that this is being very tiny for y'all. Okay, so a little bit bigger over here. I think something like that needs to happen. But again, let's muddle forward as is, and try to get things to work in this sort of like nicely squared up environment, and then we'll look at all the cases where it doesn't work and then try to figure out what we have to do to throw in to compensate for that. And again, even if the squared in environment, it'll look right, it'll technically be slightly off until we compensate for this, because even near the equator in the prime meridian, there's still a little twist that happens around there. So we've got that. So now that we've got the angle difference, right? So this is like, oh, we're 1 degree off from the center. Well, we can convert that into a distance, because what we can do is, so I mean, I guess ultimately we're making a vector. We're returning a vector 3. So we could probably use something like return new vector 3, where the x distance. Yeah, we have to remember to invert these, because the distance along like the x coordinates is going to be based on the y angle, because a y rotation leads to movement in the x direction, right? Because we're rotating around the y axis. So we're going to do something like angle difference divided by degrees per chunk. So now what we're doing, I mean, assuming this building is within this particular chunk, right? Like we've now gotten to the point here where this is now going to represent a number from, I guess, from negative 0.5 to positive 0.5. Again, if it's outside the chunk, it'll be outside of that range, which is okay because we're going to catch it in the other thing. But assuming it's within our chunk, it's going to be, because we can only be like half of whatever degrees per chunk is off and still be in. So assuming that we're within our chunk, this number is now going to be somewhere between negative 0.5 and positive 0.5, because degrees per chunk is the middle of the object. Yes, it is. So, but what we want to do is find our position relative to the chunk's transformed opposition, which is actually its bottom left corner. So we sort of need to change this to be a number from 0 to 1. Okay, or again, at this point, it might still be outside of that. We might still have a negative number at this point, or we might have a number above 1. But that's okay. That just represents something that's outside of our range. At this point, assuming that this object is within our range, then we now have a value here between 0 to 1, which we can then multiply based on world units per chunk. So now we're going to have a number that goes from, assuming our chunks are 1,024 units wide / tall, then this is going to be a number from 0 to 124. So we're going to do the same thing in not the y-axis, because this represents height of building. We don't know what that is. This job can't possibly know that. Well, it could actually. I mean, not yet. We have to put in a 0 here. But part of this function could fill out this height. But I don't think I want to do that. Anyway, we'll figure it out. Anyway, this part here, this is going to use the x angle here, because the x angle represents movement along sort of the north-south axis, which, depending on what system we're talking about, either is the y-axis or the z. In this case of the vector 3, it's going to be the z-axis. So it's it's the same as this. Okay. So this is fine, except that we do ignore rotation around the z-axis, and maybe I'll get it this time. I don't know. So if we do that, so spherical to local position should now be returning a proper position. If I try to run this, is there any chance it's going to be vaguely close to correct? Well, first of all, not if there's syntax errors. So we have a parentheses that's out of whack. Huh? Which one is it? These all seem fine. What? Unexpected symbol closing parentheses over here. Because open, yeah, I mean, you get the highlighting. Open, close. This is open, close. Open, close. Is there an error left over from higher up? Okay, well, first of all, I'm gonna do that. I'm clearly effing up something there. Yeah, oh yeah. You need a spherical, which we don't have right now. No. Oh, you need. Hang on. Oh, you want a vector 2. Yes, I can do that. New vector 2. There we are. There. So you didn't want 2 individual floats. You just wanted a vector 2. Okay, that's okay, but what? Oh, you know what it might be? It might just be this colon or this comma at the end of this. It is. Okay. I had the excess comma there. Yeah, because, yeah. Yeah, all right, that's fine. So we are now compiling. So is there any chance this is sufficient to get the building in the right place? Again, ish. There's definitely still some things left, but well, this was unexpected. It actually not only didn't put the building in the right place, it went back to spawning it 3 extra times, with a Z of like negative 73,000, minus 6. Oh, wait. Okay, one of these is right. Hey, this one is correct. Okay, one of these belongs to the wrong chunk. Okay, so this object is part of the wrong chunk. It's like up here somewhere. It's belonging in this chunk, even though it shouldn't be. It happened to put it in the right place, right-ish place, which is weird. And then this one's at negative 7,000. So 2 things are going on. First thing is, the first thing is that our filter here for telling whether something is within our chunk isn't quite working, which might be this. But amazingly, this one here, this is the correct chunk, right? No. Oh, that's funny. That's really funny. Okay, hang on a sec. Let's review this. I was not expecting this. So, okay, it showed up in 3 chunks. Now, what's funny is that this chunk here at the bottom is the chunk it's actually supposed to show up in. And it did. Coolbase does indeed belong to this chunk. But for some reason, the Coolbase that belongs to this chunk is the only one that's in the completely wrong position. Horrifically wrong. All of them have the correct X. The fact that the Z is wrong makes me think it's probably something going on with, it might be a loop around of things. Let's do I want a debug command here? I mean, I could run the debugger. I'm just trying to think about what process, what point in the loop we're in. I guess, okay, I'll do this. I'm going to say debug.log. First, I'm going to say gameObject.name plus. So that way we know what chunk we're dealing with. So we can isolate the good chunk from the bad chunk. And then I guess we're going to say we want to know what the spherical coordinate is. And then I think what we want to do is list x angle diff and y angle diff, like that. And like that. Okay. So if you're on this does take longer to run. There's one of the things we're going to do at some point is we are going to optimize both the chunk production and or move some things out to threads and things, which it's not the same as optimizing. It doesn't necessarily make it happen faster, although with a multi-core processor maybe, but mostly more responsive. But the image structure thing is definitely a bit. Okay, so the good chunk is which one? Is this one here. 512 and negative 1500. So that's the one we want to look for the comments on. So 512 and negative 1500. Now, for all these chunks, it will return exactly the same latitude and longitude of the object. That's fine. This is where the object is actually supposed to spawn. I think we can see the error here. The X angle difference is negative 360 degree 0.5. So that's just sort of got to loop around. And that will get rid of the giant negative Z that we're getting here, negative 73,000. So that's one thing. So we're going to want to say, and it was the X that was way out of whack, right? Yeah. I mean, we might want to do the same thing for the Y. But I guess I can just say if X angle diff is well, x, I mean, that shouldn't make a difference, is less than 360, less than negative 360, then x angle diff plus equals 360. I don't know if we have to worry about it the other way around. It's like kind of funny that that happened at all. If it's greater than 360 for some reason, then we'll just remove that. So let's deal with this bit first. Doesn't feel like we should have to do that though. But I don't know. Anyway. Yeah, wait. No, right, of course it could do that. Yeah, no, that's fine. That's fine. Okay. So, again, here's our working chunk. And if we find the cool base... Aha! Okay. So this is the good chunk, the one that's supposed to have a cool base. And if we look at the cool base, it appears to be in the right position, except for the height, which we're going to correct for next. If we bring the height up here, that looks right. That is basically it. That's where we have our dot. It's worth noting that the position is determined. It's like it's setting this cool base clone. This is an empty game object, and that this is the thing that's the position is getting set to. If you got to make sure that you place your stuff inside it to be appropriate, maybe centered, maybe not. I don't know. As long as you're consistent, you're going to have good behavior. So we got that. Obviously, one of the things will be smoothing out the terrain, but that I know how to do. I've done this before, where you smooth out the terrain underneath an object. That's okay. That won't be today, but that's okay. All right, so we're there. Now, the thing I'm confused about is how on earth is this object doing that? I must have, the fact that it's not breaking for the others means I have a stupid little thing. Local position X, X, local position Y, Y. But I... It clearly can't be inside your position for all of you. Because you're setting it to like negative Z. Oh. Z. Z. There we go. Not the Y. The Z. Okay. I'm going to say, but Z's coming out to like negative 600. How could it possibly be above 0? Wait a minute. So if we do this, we should only end up with a single building. And we do. And it's in the right chunk. And it's in the right place. That's great. The problem is, it's not actually 100% in the right place. It's hard to tell because there's not a lot of twisting around the Z-axis going on right now. But if we were to go to the master, and we were to uncomment this line to give us a 45-degree twist, it becomes very obvious that not all is right in the world. In particular, I don't think we'll get a cool building at all. And in fact, we don't, and that's because it's over here. If we pair this with our landing spot, if we give it something like a -3 here on the landing spot, which I think is inverted from what you would expect, but we'll sort that out after. Hit play. There we go. You see, like there should be a cool building over here, but there isn't. And if we bring this over more to about a 4, now all of a sudden we will get a cool building, assuming that we've matched a couple other things along the way. We will get a cool building, but it'll be in the wrong spot. It's in the right chunk, but it's in the wrong spot. If we just bring it up to, I don't know, 250, that should be above the ground. Yeah. You see it spawning over here instead of here. Now that's because we're not making use of the rotation here. Not here. Here. Right? Because there's a Z component to the rotation to our chunks. So, if we... I don't know if this will work. But if we have a quaternion, which is our building quat. Now, we have no way to just convert from a rotation to a quaternion. Even though it's... Oh, no, we do have spherical to rotation. Yeah, I was going to say, it's really trivial to do. But, ideally, I'll use a helper for it. So we've got a chord helper dot spherical to rotation. So SC gets converted into that. Now, let's make sure that just doing this doesn't break anything. And it shouldn't. Because what I can do is, instead of using SC.latitude, I can build using building quat dot Euler angles dot X. And here, instead of using the longitude, we'll use the Y. So just to confirm, I'm not using the SE anywhere else. Good. Okay, so if we do that, and I remove my changes to the master here, right? We go back to a 0, and we go back to a 0 here. I want to make sure we haven't broken what was working. I should have a Boolean or something like that, so I can just turn it on and off to quickly move the world here for this test. You're here, you've got your cool base. If we bring you up to 250 in the Y, you're still in the right position. Okay, that's fine. So then if I undo, now we're going to be a twisted version. And so the question will be, is this going to fix things to get our things to be in the right spot? Play. No. It still spawns. Well, it's... Is it closer or is it exactly the same off as before? I don't know, but it's still not here. So the problem is I can't sort of... Oh, well, we're not doing a rotation, right? We haven't changed anything. So clearly nothing's worked. Shut up, I'm fine. We're going to take... We're going to take what? I was going to take this and multiply it by... We can't just multiply it by our chunk rotation. I could make a new quaternion just using the chunks rotation dot Euler angle dot Z, but this is not the this is not going to do what we're looking for. But I'm sort of starting to get a bit of a sense as to where we're a bit off. I mean, there's no way that this does what we're looking for. Yeah, no. It hasn't made any appreciable change whatsoever. Which makes sense, because this wouldn't actually modify the XY of that. So... So this is where I'm a little bit stumped. I guess we don't have to rotate it first, actually. Because, I mean, we're still, at this point, we're still comparing... Okay. We need to... It's the X and Y that we got to rotate, isn't it? After we've got these bits. Let's think. Let's go back to... by thinking, I mean, let's go back to Photoshop for a second. So, what we've got is we're calculating... We get the center point, and we've got our building over here. And we're getting this distance, right? That's what X angle diff is. And I mean, whether we're talking about the X angle diff or the distance diff, that's the same. It's just a question of, are we talking about the distance in terms of degrees or absolute distance? And that's fine, and that's true. But then what happens is, if effectively our chunk is rotated, what's happening is we're here, and we're reporting our latitude and longitude as being blank, and it's like, so that's here, so that's the distance, but it's not, because really, hang on. So I'm reporting as being here, like same distance. Let's assume that this arrow is about the same as that. So that's okay, except that really what we need to do is rotate it afterwards so that our distance stats are reporting this. Right? Right. So our X and Y angle diff, we need to rotate. But actually, could we just rotate the vector? could we take this and we have to put the return in first all the time. Could we return? I don't think this will work. And at this point, I'm probably going to stop and let someone just smarter than me figure it out. Chunk rotation.eulerangles.z. If the vector that we're sending, we rotate same as the chunk, hit play. Play, play, play. Come on, play, play, play. First of all, we got 2 chunks. Secondly, is it just me or why is there Y? Oh, wait, hold on. Okay, we need to rotate it. It's going to be a little weird. We're rotating this vector around the Unity world space y-axis, but we're using the chunks Euler angle z-axis. Okay, maybe. Oh, wait. And then that's... Okay, now it's reporting nothing's in chunk, but the problem is this. What we're rotating at this point is not the vector that represents the distance from the center, which is what we want, but rather what we're rotating at this point is the vector that's from the bottom right corner to here, and it's going to rotate in entirely the wrong sense. So what we need... Okay, so we've got the angle diffs. What I need is I need a vector 3, which is dist from center, which is going to be equal to, it's basically the same as what we're doing here, except we don't add the 0.5. So now that we have a vector that describes the distance from the center. Rotate the vector based on chunks rotation. So we can say dist from center is equal to this weird rotation where the z is in the y component, but I think is correct. The problem is, like, there's so many goddamn steps here that there's so many places where I can completely screw up the math. So that has been rotated, and then what we have to do is move it to the bottom left corner. Now move the vector's origin to the bottom left corner and return that. So what I can return is the distance from center plus new vector 3, where we are going, what, minus 512, minus 512, 0? Or, sorry, not the height. My brain's starting to melt a little bit. Wait, recorded so much of the stuff today. This episode's gone on way longer than intended. I'll probably have to chop it in 2, actually. No success. Like, at this point, I'm just starting to, like, guessing a couple of things here. Like, oh, what if I just invert these? Is that right? And I mean, I realize I'm hard coding in those numbers, too, which is not good. Which is really not good, because I don't think... I actually don't know for sure that our world chunks are 1024 anymore. So, I guess I'll have to output some more stuff. Now, again, at this point, if we were to go and remove our rotation, yeah, I should use a Boolean. And, oops. Yeah, bool rot test equals false. Rot test, question mark, minus 4 or 0. And then over here, if rot test, do that. Okay, so we've set it to false, so this is going to be no rotation. This will indicate to me a little bit more clearly if a couple of things are effing up or not. Cool base, is in the right position. Okay, so that means that currently this offset is working okay. It's this rotation step that doesn't work. And I'm... Fix me. I am wrong here. Make math more better, please. I think my logic is okay. I think I'm just effing up the implementation, and I can't anymore. I can't brain anymore. I've been doing this for too many hours today, and rotations mess me up. On the bright side, I think what I could do to make things feel a little more happy is not bother doing this conversion to a quaternion, because we're not doing the change to the quaternion itself. So I could just go back to using the spherical coordinate directly. On the other hand, this has a nice symmetry here and here instead of mixing latitude, longitude, and Euler angles. So what the hell? We don't need to pre-convert. There's something, either this is wrong or not doing enough or something. Any chance it should be like no. No, I don't think so. I'm gonna try it. Okay, wait, I'm running it with no rotation test, which this should again make no difference. You know what'll be a little less annoying? And here, I can throw this in just to help in my mind chopping this into 2 episodes, even though it's already 46 minutes long. Good God. Is I'm going to make the height come out correctly of this thing. So again, spherical to local position, I'm not going to include the height data in there because it feels not right. But instead what we're going to do is fix the building's height, which is, so our terrain, we can sample the height at a particular world position. Okay, so we should wait until we've got the global position. Can never remember if it's local to terrain or if it's the world position. Okay, so if we feed in a global position over here, this will return height at global position, like that. And this will correctly interpolate as well, because we might not be right on a array grid for our terrain. It might be in between them. So we're going to get some sort of height. So our global position dot y is going to be set to this height at global position. Setting this rotation isn't going to help solve our problem, by the way. This is just setting this will make sure the building is twisted in the correct orientation. Is it a latitude longitude thing? Do we need to incorporate longitude? I think we do. Let me get back to you. Because the rotation of our object is, and again, this is just our orientation once it finally gets spawned. It doesn't help us put it in the right place. This object is going to have some rotation through the world y-axis, which is going to be equal to the chunk rotation dot Euler dot z plus our actual longitude, I think. Now again here, I'm going to run it, I believe this is without the rot test, so it should mostly look exactly the same, because there should be very little rotation involved. Just a little twisting based on the chunk. Ah, you can see our height is working okay. That's nice to see. And if we look at our cool base over here, it is twisted because this chunk actually has, in truth, a little bit of twist. Instead of reporting the coordinates here, for these chunks, what I'm going to do is, and that's in master here, I'm going to just change it real quick to report rotation.Euler.toString. So now these chunks are going to be named based on their rotation, and we're going to see that that chunk has a slight rotation around the z-axis. Or I'm wrong. Right. Yeah. No. Not. Yeah. No. I guess not. I'm sure this is going to have to be a thing, though, because again, if we look at my glorious drawings on this level, remember that at 90 degrees longitude it needs to be offset. If this isn't offset, which it's not, therefore that may or may not be accurate for that building. It actually might be. This is going to be one of those questions, I think, of there's going to be some map distortion. Should the building be flush up to here or not? Because the longitude line from this actually is going kind of like that, or something to that effect. That's not actually true, because if this were here, it would still be offset. So it's got a... This twist is dependent on the... Oh, God. On whatever the center is... and what latitude we're at, because that 90-degree twist only is true if we're at the bottom. Oh, actually, yeah. So, I mean, would it be a question of doing a sine over here? MathF, I don't remember if it's cosine or sine that goes to 0 as you go to, I think, sine, right? So if we take a look at our current latitude, it's going to be something like that, although... If we sine that and then multiply by that, although this wants radians and this is in angles, so we need a mathf dot degree to radian multiply by that. This will result in almost zero twisting whatsoever at this point, because we're so close to the 0 latitude. Yeah. It's there, but just barely. And it may not be right. But fix me. Well, it's more like test me, especially near the poles and with different chunk rotations. I suspect that it is not accurate. But anyway, let's go back over here. We're going to do our final little tests here. We're going to set rotation test to true. At this point, I'm starting to forget like all the things I did to check that I'm going to want to check and unbreak here if there's something. Okay, we are getting our cool base. Is there... Wait. So, wait. Holy crap. I'm so happy because I tried so many times today and I did not get this right. But somewhere along the way, it's not what we were just working on. This, which is what we just did, right? If I put this back to quaternion dot identity, right? I'm just going to put this back to quaternion dot identity, right? That is not what we fixed. There's some other thing that I just did, and it's like I'm going to have to rewind my own video about 10-15 minutes to see what it was. This is now spawning there correctly. Holy crap. Doesn't mean it's working. There's probably all kinds of problems still at the poles or whatever. Holy crap. That's huge. Because that's where it's supposed to spawn. So again, the orientation isn't actually right. If I go and do this, was it actually orientating itself probably okay? What we'll have to do, actually, we'll have to make a cool building where it's got one side that clearly labels which side should face north. Yeah, I mean, it's angled, so it's properly perpendicular to this. It might be 90 degrees off or 180 degrees off. That's what I'm saying. Like, that might still be a case. But we're most of the way there now. Oh, good God. Again, we still have to stitch things, and there might still be a little inaccuracy going on with there. I don't think so. Next episode, what I really want to do, though, is I want to get rid of this problem, which is going to be so fine. Totally okay. Probably. I've done it before, so probably I can do it again. What we're going to do is auto-flatten the terrain underneath our object over here. So that, because what it's doing is the object is being placed such that the midpoint of this, whatever, like our actual cool base empty game object here, wherever it is getting positioned, it's getting positioned so that its Y is flush with the terrain just underneath it. So just over here, it's like perfectly flush. But that means some parts might be too high, some parts might be too low. So what we're going to do is flatten the terrain under our buildings using an automated process, which is going to be okay. That makes me so happy. Once I get that, now the flattening of the terrain wasn't actually something that was specifically asked by Mr. the MightySpud when he commissioned this project, but it's something I feel very strongly that I want to do because it's going to look good. After we do that, what we have to do is get our code to leave the planet, go back into sort of space mode, right, which I still have here. Yeah, right. Go back into sort of space mode. And from space mode, be able to land back on our planet back and forth and have those things line up. Basically, we're just going to be, trying to, this whole thing where we call like sort of build from landing spot, it's going to be that sort of thing. So there's still going to be, a couple of things that are a little bit, need some tweaking here and there. We'll get the terrain stitching up. And then there might be actual just bugs or something, but I'll probably bring the project to a close at that point. And of course, everything will be available on the interwebs for people. So thanks for watching this. Maybe I won't put a cut. Maybe I'll just upload it as one like double episode because the cut might be a bit awkward. So maybe I'll do that, but I'll call this a double episode. You know what made the big difference, I think, here is explicitly making sure to feed this into a separate function, because I was trying to do too much in one big chunk over here. So again, I'm not sure. Again, we can check the polls. The polls might be way off. I don't want to go there right now because if it breaks, then I'm just going to be frustrated that it's not working right. So we'll check the poll situation later on. Thanks for watching, folks, and I'll see you next time. Thank you, all our March Patreon supporters and these Mic Check supporters. We've got Yukofin, Snoopy TRB, Pavel Zdenov, Drazion, Gavin Power, Jan Torre Vel, Michael McClintock, Aaron Doibson, Craig Mortel, The Not So Evil Engineer, Julian Ogenafon, Marisfield-Vold, Speedy Savant, Steven Stager, Valiant, that's probably Stager, I don't know, Valiant Cake Fiend, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil Blakely, Milner, and everyone who has watched, shared, favorited, and subscribed. Thank you so, so much.